Hi everyone. In the previous tutorial of the beginner series, we discussed about how to conduct analysis on an Etabs model. In this tutorial, we will be discussing about the reinforcement detailing of columns and beams in Etabs 2015. To make this tutorial a bit more simple, I would like to select the ground floor by making just beams and columns visible. So here, we will be focusing on a single beam, that is of size 240 into 500 with the label of B42 and the adjacent columns of this beam B42, that is C25 and C10, both having the same size or equal size of 240 into 400. So next, let's go to the most interesting part, that is the structural detailing. So after the analysis, go to detailing and select the first option, that is detailing preferences. So here under standards, I'm selecting the metric as my units, and under dimension units, I'm going to give meter for the length, and for section and rebar spacing, I'm going to give millimeter as my units, and for force, I'm going to give kilonewton. And under material quantity units, I'm going to give for rebar length, slab area and concrete volume and also the rebar weight as meter, square meter, cubic meter and ton. And after making these selections, click on OK. And then next, we go to the concrete component preferences. So here, let us first select the beam. So here under the beam, what I need is that the visible in frame elevations, that is section name and sequence number. And let's click on OK here. And under next, under the column, it's the same over here. You can just select whatever you require. And after being done with the concrete component preferences, next is the rebar selection rules. So first, let's go to the beams. So here, under the beams, you can see there are two options being provided. One is non-seismic and the other one is seismic. So I would like to detail my beam with respect to seismic requirements. So I'm selecting it. And here in this table, you can find that it has been defined or it has been divided into two different sections, that is longitudinal bars and the stirrups. And under the longitudinal bars, you can find that 7 different names has been given to the bars, that is from A to H. And in the stirrups, it has been divided into 3 different zones, that is A, B and C. So next I would like to show you a typical design section of a beam that has been defined in Etabs 2015. So you can get a better idea about what are these alphabetical orders and these zones referring to. In this typical concrete beam elevation, you can find the names A, B, D, F, G and H that is being provided for the rebars of this beam. Here A refers to the top rebar of this beam and the F refers to the bottom rebar. B and D corresponds to the extra rebar that has been provided at the top from the beam column joints, and G and H corresponds to the bottom rebar. And here you can see our stirrups has been divided into 3 different zones, that is zone A, B and C, where A is the end zone and the C is the central zone of the beam. For more details, you can read through the notes that is being listed here. So here, I have already defined the rebar sizes for both longitudinal and stirrups. So under the bar size, you can just select any bar which you require, which you need to input into this table. So here under the smallest bar size, I have provided a 12 mm diameter bar for the longitudinal bar, and for the stirrups is 8 mm diameter. And the largest bar size that is considered for the longitudinal bar is 32 mm diameter, and for the stirrup is 12 mm diameter. As I am designing a commercial building, the preferred bar size for my main bar is 20 mm diameter and for the stirrup is 8 mm diameter. As you have seen before in the typical concrete beam elevation, the main rebar names are A and F, so I'm giving a minimum of 2 number of bars for both A and F, and I'm leaving a minimum number for the rest of the names as 0. And under the maximum number of bars, you can either input the maximum number of bars, but I prefer to leave it as it is. So under the stirrups, I'm giving a spacing of minimum that is 75 mm and a maximum spacing of 300 mm. So next, let's go to the column detailing. So select the columns, and here you can find two options, non-seismic and seismic. So here we're going to define the seismic, and here as similar to the beams, we have the longitudinal bars and the ties in the columns, and the ties has been defined in three different zones, that is zone A, zone B and zone C. So the smallest bar size in the case of main rebar that we have adopted is 12, and the case of ties is 8, and the largest bar size is 32 and 12 in the case of ties, and the preferred size is 20 for the main bars and 10 for the lateral ties. And here we are going to splice every bar after 2 stories. As our commercial building is a G+4 building, we are going to splice a bar after the second story. And here the minimum number of bar quantities that has been defined is 4, as the columns that we have defined is a square or a rectangular column. And here the minimum spacing provided for ties is 150 mm and the maximum spacing is 300 mm throughout these 3 different zones. And let's click on OK. So now we have finished defining the rebar sizes of both beams and columns, and now let's start detailing our model. So go to detailing and select the start detailing. So now the detailing has been done, and you can see a model explorer dialog box that has been just opened at the left. So next we need to locate the beam and the adjacent columns that we desire to apply the reinforcement. So let us start with the beam first. So for that, go to the drawing sheets from the detailing option, select the floor framing plans and click on this one. So now the framing plan is visible. So let's zoom it to find our beam. So this is actually the beam that we desire to apply the reinforcement, and it is being named right now as 4CB13S1, where CB represents the concrete beam and S represents the span. So this is 4CB13 with the span 1. We will understand the naming when we go a bit more further. And next we need to find the names of these 2 adjacent columns. So for that, go to the first option, that is drawing sheet component views, and select the column details and select the framing plans, and here click on the concrete column layout. So this is a beam that we have just located, and these are the 2 adjacent columns, and the names are CC20 and CC9. So next let's start with the detailing part of it. So let's start the detailing of the beams first. So under the drawing sheets, you can find the concrete beam schedule with respect to seismic loads that has been listed in 4 tables. So let's select the 3rd table and let's find out whether our beam is being detailed in that. So now you can find a set of beams is being shown here. With respect to the beam ID, span, the section size and the main bars, and also with respect to the stirrup and the typical elevation. So here our beam is 4CB13S1. So this is our beam actually. So it is being shown 4CB13 and S1 is a span 1 here. So this is a beam with 5.46 meter length and with the section 240 into 500. And with respect to this line, you can find the main bars and the stirrups as we provided. For a better view, I will show an abstract view of it. Here you can find that our beam number 13 with respect to span 1 has been detailed. So the main bars has been provided at locations A, F and B, and the stirrups has been provided at 3 different zones, that is zone A, B and C. And with respect to span 1, our typical elevation is elevation 3S. So next let's see the concrete detailing. So for that, under the drawing sheets, you can see 3 concrete column schedules has been listed here. So let's start with the first schedule. And here our column names that we are looking for are CC9 and CC20. So here you can find the CC9 is been listed here. So here you can find the column size, the section name, that is section is A over here, and the reinforcement that has been given is 1225, and ties at A, B and C zones are given as 10 at 150, 10 at 150 and 10 at 150. So if you need to find this section here over here of the column, we can just go to the standard details and go to the column section A, and this is the section A that is being given for our column. So in similar manner, we can just view the detailing of our next column, that is CC20. So this time we'll go to the third table, and here you can find that the CC20 is being listed here, and in a similar manner as I explained for CC9, the column size, section, reinforcement and the ties at the 3 zones has been shown under CC20. To have a 3D rendered view of reinforcement in a column and a beam, just go to the left and select the reinforcement cage views, and from the drop down let's first go to the beams. So here let's select the first one itself, 7CB1. So here you can see a 3D rendered view of a beam. In similar manner, you can go to the columns, and let's go to CC20 right now here. And this is a 3D rendered view of a column. With this, we come to the end of this tutorial. And if you have any doubts regarding this tutorial, you can just post your comments in this YouTube channel below this video, and please do share and like this video, and make sure you subscribe this channel for the upcoming tutorial videos.